Here are the materials we used to construct our motor: electric tape, sandpaper, scissors, paper clips, D-battery, permanent marker, and magnetic wire. To construct our motor, I decided to first create the loop. To create our loop, I used magnetic wire, and I wrapped it around our D-battery 7 to 8 times. Then, with the loose ends, we wrapped each side around the loops 3 times to secure the loop. We used scissors to shorten the ends to an appropriate length. Once we had the loop, we stripped off the insulation on both sides of the wire entirely using sandpaper. We then used permanent marker to shade half of each side so that half of each side of the wire is insulated. Here is our completed loop, and if I flip it around, you can see that one half of each side is shaded with permanent marker. Next, we used electric tape to tape one paper clip to each side of the D battery. We then threaded each side of the wire from the loop through the holes of the paper clips. I will demonstrate.
Now, let's talk about our theory on how the motor works. When the looped wire is placed on the paper clips, the circuit is closed so that there will be current going through the looped wire. And because there's also a magnetic field due to the magnet right below, there will be forces exerted on the looped wire according to FB equal to ILB. If the looped wire is placed vertically, the current in which is going counterclockwise and the magnetic field is directed downward. By applying the right-hand rule, the direction of the magnetic force exerted on the top side of the looped wire will be going towards me and away from me for the bottom side. There's a net torque on the looped wire causing it to rotate in the direction of the finger's right thumb to the right. You might wonder what's the point of scraping off some of the coating on the wire. Because the coating is insulator, it has to be removed in order to let the current go through the wire from the paper clips. Here is some visualization of the looped wire when it's rotating. Let's consider a looped wire being placed vertically on the paper clips, and let's call this position 0 degree. In this position, the current in which is going counterclockwise and the magnetic field is directed downward. In this position, the looped wire possesses a net torque in the direction right thumb to the right. Now, it turns 45 degrees since the directions of both the current and magnetic field don't change. So do the magnetic forces. The net torque will be less than before since the magnetic forces aren't completely tangent to the sides of the looped wire. At 90 degrees, the magnetic forces are exerted on the axle, so no net torque. At 135 degrees, the net torque is in the opposite direction since the direction of the magnetic forces remain the same. Same thing at 180 and 225 degrees. At 270 degrees, the net torque is 0 again since the magnetic forces are exerted towards the axle. At 315 degrees, the direction of the net torque changes back to before. So if scraping off all of the coating on the wires contacting the paper clips, the looped wire would simply just oscillate due to the change in direction of net torque. Based on the information known, only the sides of the wires contacting the paper clips when the looped wire has rotated 0, 45, and 315 degrees needs to be scraped off. Or in other words, the entire half side of the wire that will exert the same direction of torque. After scraping off half of the wire, the looped wire will accelerate in one direction. In this case, if the current is going counterclockwise and the magnetic field is directed downward, it would rotate in the direction of the finger's right thumb to the right. When it rotates to the sides with the coating, there won't be any torque in the opposite direction since there will be no current passing through the looped wires, so no magnetic force. The momentum of the looped wire will carry it to rotate until it reaches the sides without the coating, and it will accelerate again due to the net torque, and so on. Another explanation on how the motor works is that when the current goes through the looped wire, since it's looped, it acts as a solenoid, which generates a magnetic field. So essentially, the looped wire turns into a magnet. If there is no coating on the wire contacting the paper clips, the looped wire would always want to align up with the magnetic field from the magnet beneath it. So half the sides of the coating on the wire has to be removed so that the looped wire won't gain an opposite direction torque. Similar concept as before. And now here are some things you can change to alter your motor. What would change the direction of rotation? The direction of the battery installed will change the direction of current going through the looped wire, as well as the direction of the magnetic field. These two factors will change the direction of the rotation according to the right-hand rule. What would increase the speed of the rotation? According to the equation I equal to V over R, when a battery with increased voltage is installed, the current going through the looped wire increases, so the magnetic force also increases according to FB equal to ILB. Thus, the net torque increases.